Hello, class. This is our lecture about the properties of solutions. And by the way, guys, this PowerPoint is based on the book of Chemistry, the Central Science by Theodore Brown, Eugene Limay, and Bruce E. Bursten. And if you want to download this PowerPoint, just kindly click the link below and you will get the PowerPoint. The PowerPoint is not mine, so we downloaded from the internet. Okay? So let's start. Okay, the outline of our discussion for today, we will talk about the dissolution processes, the types of solutions, the ways of expressing concentration of solutions, and the colligative properties, factors affecting solubility. So those are the topics that we are going to discuss. We are going to discuss for today. So let's have a little bit review. Mixture, okay. You all know this, that there are two types. Mixture is a combination of two or more substances that do not combine chemically but remains the same as individual substances when they combine, and can be separated by physical means such as evaporation or distillation. And there are two types of mixture, namely heterogeneous and homogeneous mixture. The heterogeneous mixtures means hetero. The difference of this is that this one, the example of this contains banana, peanuts. You can separate it by filtering or by any physical means, such as yun nga, yung separation of sand with iron fillings and rocks. So those are the heterogeneous mixture because they are visibly different substances, okay? And then the other type is the homogeneous mixture, means the same. Now, when you mix this, let's say the solution of the sodium chloride solution, when you mix salt and water, the salt is not visible to the water because the solution process is cured. Now, it is a homogeneous mixture because it maintains one phase, which is the liquid in the salt water. Now, it is commonly referred as solutions. So this is the focus of our lecture for today, the solutions. Okay, now let's start. So there are actually types of solutions, named gaseous solutions, which is the air, liquid solutions, which is the drinks, such as this one here, and salt water, and then the solid solutions, such as alloys. Now, the focus of our discussion is the liquid solutions, which is the solid dissolved in the liquid, or the gas dissolved in the liquid. So liquid solutions is the focus of our discussion for this one. So what is solution? Solution is a homogeneous mixture of two or more pure substance, commonly known as the salts. Ayan. So in a solution, there are two components, which is the solute and the solvent. The solute usually is the substance that is dissolved in a solvent, which is the dissolving medium. So the solute, let's say this one has a lesser mass, and this one here has a higher mass when it comes to liquid. But in terms of solid plus liquid, the solute is the solid and the solvent is the liquid. So these are the types of solution that discussed for this one here. And as you can see here, the state of the solution here, as discussed earlier, the solvent and their solute. So these are the common examples of it. So this one is the solution. So we have gaseous solutions, we have liquid solutions, and we have solid solutions. So this one here, since we are focusing on the liquid solutions, this one is a molecular viewpoint for the dissolution of sodium chloride in water. And as you can see here in the dissolution process, that we all know that the sodium chloride contains sodium ion and chloride ions, ionically bonded to each other. So when you dissolve it, so it will dissociate to form sodium and chloride ions in water. It's also known as magkakaroon tayo ng solvation process. The solvent will pull the solute particles apart to solvate them. So ang mangyayari dito, nakikita ba dito? Ayan. So we have the water. We all know that water has a partially negative part and a partially positive part, which is due to their differences in electronegativity. The sodium chloride contains sodium chloride ion. The sodium ion will be bonded in dipole-dipole interaction, tawag dyan. dun sa may negatively part. Because dun nga, di ba, sa may magnet natin, the positive attracts the negative and vice versa. Samantalang yung chlorine naman natin, the chloride ions, when it comes to the solution process, ayan, kung mapapansin ninyo, is bonded to the partially positively charged of the water, which is the hydrogen. So ayan, yung mangyayari, these are the explanations of ion-dipole interaction pala yun. Sorry. Ayan, so lattice energy will be to overcome the lattice energy of the crystal for the dissociation of the sodium chloride ion. So that's how the solutions form. But when we look at it in a thermodynamically, the value of enthalpy is involved for the dissolution process. Now consider there are three factors affecting the energy of the solution produced. So it can be either endothermic or exothermic, which we will be tackle on the later on of this lecture. Ayan. So first, enthalpy is the separation of solute molecules or the sodium chloride. And then the separation of solvent molecules, kasi nga nagkakaroon sila ng interaction, di ba, with the solute particles. And then the formation of solute and solvent interactions. So there are three enthalpies that you have to consider to get the enthalpy of the solution process. And when it comes to this, ayan, so it contributes to each step depending on the nature of the enthalpy or the value of enthalpy it may yield. And as you can see here, for the dissolution processes here, it is an exothermic process because the separated solvent particles and separated solute particles, enthalpy of it is higher than this here, than the two phases here. So the net enthalpy has a negative value, which is as we all know, exothermic process. So that's the enthalpy of the dissolution process. So ayan. And then this one here, exothermic, meron din naman tayo, syempre hindi mawala exothermic. And ang nito is it doesn't occur spontaneously. An example naman ito, guys, for the endothermic process of dissolution, as you can see here, ayan, no? These are the processes, ayan, and as you can see here, it is covered by three enthalpies here. The solute plus solvent interaction and the solute-solvent separated molecules is higher than enthalpy 1. As you can see here from the graph here or illustration, ayan, so it is in it. Endothermic process, and a common example of it is the dissolution of ammonium nitrate in water. Heat is absorbed, is released, so freezing will be occurred during crystallization. Depends on what the experimental result that will occur for the dissolution of ammonium nitrate in water. And next one here, as we all know, we tackle the word spontaneous. So gives free energy is related to this one. Because enthalpy, as stated here, is only a part of the picture because i-consider natin yung entropy or the Gibbs equation. Ayan nga. So the disorderness or randomness of the equation of the system that tends to lower the energy of the system. So kung familiar ka sa may equation na gatas or delta H is delta G is equals to delta H minus temperature times entropy. So related pa rin yung equation na yun. Ayan. So here again, it's just a precaution for all you all na hindi ang ibig sabihin lang nito na porket na dissolve yung substance, dissolution na yon. Hindi tandaan niyo that the dissolution process is a physical change, not a chemical change. Ngayon, paano ba natin makakuha nito? Example, this solid one, what's this one? Ayan, yung hydrochloric acid with mercury. Ayan, so you will yield this. Nagkaroon tayo ng, I think this one here is a mercury chloride. Okay, tandaan niyo, ayan, it is a physical change. Now, it is separable. Para ma-separate nyo yon, you have to vaporize the water or the solvent or whatever the solvent is. And matitira doon yung solid. Pero but, once if the substance didn't dissolve, it reacted. So chemical change. Tandaan niyo, the solution process is a physical change, not a chemical change, as stated in here. For the reaction of hydrochloric acid with mercury, yield this, so nagbago yung kulay. So as we all know, it is one of the indicator of the chemical change. Yan. So naging, I think this one is here is a mercury chloride. So ayan, we have also types of solution. Okay, types of solution. Depende doon sa may amount of solute dissolved in a certain amount of solvent. Diba? Hindi yan yung gaseous blah 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 yung kanina. We have saturated solution, supersaturated, and unsaturated solution. When saturated naman, okay, ang indicator doon sa experiment ninyo is you have sodium chloride, asin at tubig. Pag haluin niyo, kahit gano'ng kadami, sige, boost na kayo ng buhos. Kapag wala nang natitira doon, wala nang nade-dissolve na asin, nagsesettle na lang yung powder doon sa may baba, it is a saturated solution. Tandaan niyo, nakaka-affect na din doon yung ating temperatura ng solvent natin. Okay? So, ayan. So, dissolved solute. So, sila ay naka-equilibrium. Na state of equilibrium. State of equilibrium when saturated. Holds solute as much as solute possible at that temperature. So, nakaka-affect yun. So, sa unsaturated naman, okay, kunwari, we have 100 grams of water, tapos na-dissolve lahat, wala kayong nakitang powder na nag-settle sa may baba ng ating baso, let's say, sa baso ay na-dissolve. So, it is unsaturated. Sa supersaturated naman is, ayan na, magkakaroon na tayo ng crystallization process. Kasi nga, this one here, kung mapapansin ninyo, supersaturated, the solvent holds more solute than is normally possible at that temperature. So, ang ginagawa ninyo dito, let's see, ang experimental for you to perform heat is mag-dissolve kayo ng ano ba to? Naphthalene, I think. Ay, hindi, wag naphthalene. It's insoluble. Ano ba? Let's say sugar. Sige, sugar. Or copper sulfate. Ayun, copper sulfate. I-dissolve copper sulfate. Tapos, naglagay ka ng lagay. Tapos, dun sa dito sa may earthenware plus na to, is may nagsettle na powder dun sa ibaba. Tapos, in-increase din yung temperature. And then, once na bumababa yung temperature, crystallization process may occur. Kasi nga, mas marami na yung naho-hold yung solute ng solvent at specified temperature. Tapos pababa na ng pababa, ganito yung mangyayari. So it is a supersaturated. Okay, tandaan niyo, saturated and supersaturated solution. It is dependent on the amount of solute present in a specified amount of solvent. And then, syempre, there's also factors affecting solubility of solids. Tandaan niyo, this is a solids. Ayan. So, syempre, another one is temperature. We all know this. Increased temperature, increased solubility. Mas maraming solid na mapuproduce. Then also, particle size. Okay, smaller particles tend to dissolve faster than a bigger particles. And then number one here, syempre, ito, shaking or the degree of agitation in a more formal term. Ayan. So, syempre, ang example nito, syempre, di ba, kung nagtitip tayo ng kape. Di ba? Yung kape nilagay niyo sa mainit na tubig, 'di ba? Mataas temperature na tubig. Pero hindi pa rin natutunaw yung kape. Ang init-init noon, 'di ba? It is one. Siyempre, 'di ba? I-shake mo siya para mas ma-dissolve, para mas marami yung collision or the interaction of the solute with the solvent. So it is shaking for degree of agitation. Pero ang isang factor lang yan is for solids. Napunta naman tayo at another molecular viewpoint. Ito tayo sa may covalent bonds or the mga alcohols, if you're familiar to this. By the way, nataan naman sa organic chemistry ninyo. Ang rule of thumb lang naman dito is the like. Dissolves like. Polar dissolves in polar, non-polar not dissolves in polar, but non-polar dissolves non-polar, and so forth. So, ang example nito is this one here. Kung papapansin ninyo, infinity yung solubility with this hexane from the other. Ito, H2O. Kasi tandaan niyo, another term that we have to consider is the hydrophobicity and hydrophilicity of the molecule. When we say hydrophilic, it is water-loving. When we say hydrophobic, it is water-hating. So ayan, we have to consider the molecular viewpoint. So another factor here is the intermolecular forces of attraction, which is tackled on your organic chemistry. We have dispersion force, we have dipole-dipole force, and hydrogen bonding. Now, this one here is a hydrogen bonding, so it is a intermolecular forces that tends to be soluble to one another. When this one here, kung mapapansin ninyo, balik tayo dito. Ito kasing dalawang to, hindi pa dito dominant yung dispersion force natin. What is dispersion force? It is the presence of the hydrocarbon compounds doon sa may kwan natin. So, equal pa. So, madidissolve pa sila sa water. And then, after some time, ayan na, here. So, mapapansin ninyo. Ayan, so, hydrophobicity. And this one here, kung mapapansin ninyo, H bonding, this one will not dissolve in water. This one will dissolve in water, but because due to the hydrogen bonding site. Samantalang dito, pares lang naman yung kanila, di ba? Molecular structure similar. Pero ba't yung cyclohexane is hindi na-dissolve dun sa water? Samantalang itong glucose na dissolve. Kasi nga ito, it is a dispersion force. It doesn't contain a hydrogen bonding. When we say hydrogen bonding, the O and F is bonded to the hydrogen. Kasi nga, yun yung most electronegative atoms present in the periodic table. So, ayan. So, ayan, non-polar compounds dissolve, ayan, and vitamin C is soluble in water because it contains a hydrogen bonding. So, keyword lang dito, kung mapapansin niyo, is the OH bond. So, mapapansin niyo here, dominant dito yung hydrophobic part kaysa dito sa water, di ba? So, mas dominant to, it is a dispersion force. So, hydrophobic. And this one here, kung mapapansin niyo, there are 4 sites of hydrogen bonding na kung saan mag-dominate sa molecule. So, it is a soluble in water. Okay, tandaan niyo, H bonding, hydrophobicity, and hydrophilicity and site of hydrogen bonding when it comes to factors. Yeah. So, predicting solubility patterns, okay, this one is a one. Dali lang naman to. Non-polar solvent, carbon tetrachloride, CCl4, so non-polar. This one, is this a non-polar or polar? Siyempre, ito ay polar. When you draw the molecular structure of it. This one is non-polar or hydrophobic. So, this one will dissolve in carbon tetrachloride. Now, itong dalawang to, sodium sulfate and hydrochloric acid, actually, this one is a pang ionic compounds yan. And they didn't dissolve in non-polar solvent, carbon tetrachloride, rather in water. So this one here is insoluble with the non-polar solvent carbon tetrachloride. And then this one, this here is I2, it is a dispersion force. So it is a soluble in the carbon tetrachloride. So these are the answers. Ayan. Next one here, predicting solubility patterns in water. So, ang titignan nyo lang dito is the number of hydrogen bonding. So, ang mauna dito, syempre, may sagot na tayo. This one, ito yung increasing order. Okay, increasing order, this one is the least because it doesn't contain a hydrogen bonding. Tama. So, it is a dispersion force. This one here is a dipole-dipole force due to the presence of the Cl or chlorine atom. So, this one here is for the second. And then, saan dito yung mas soluble sa water? Siyempre, yung mas maraming hydrogen bonding. This one will be the second to our spot, and this one will be the first, and this is the in order of increasing polarity and hydrogen bonding. Okay. Next naman tayo, siyempre, temperature. As we all know, this one here is for the solid solutes in liquid. And as you can see here, as the temperature increases, their solubility also increases. Ayan. And syempre, depende rin sa may property nung solid. As you can see here, our cesium sulfate here, bumababa yung solubility niya when the temperature increases here. Ayan. And then another one we have to consider is the opposite. The solubility or the concentration of gases with respect to the temperature when dissolved in liquid, it has a inversely proportional relationship. Kaya nga mapapansin ninyo daw yung ating soft drinks ay nakakit dun sa refrigerator para hindi natin. Yung carbon dioxide is hindi mag-escape. Para mas na-dissolve lang siya doon sa may ating tubig. So ayan, no? Warm lakes have less oxygen dissolved in them than cool lakes. Kaya nga, di ba, sa may dissolved oxygen, biological dissolved oxygen natin. Ayan, so biological oxygen demand pala. So, mas mataas yung temperature ng body of water, mas kaunti oxygen dissolved. So, makaka-affect yun sa may aquatic environment natin for sa mga marines. So, gases in solutions, syempre, ayan. We have to consider, ikuan ko lang na lang, the solubility of gases, syempre, mas maraming liquid, mas mataas yung solubility ng gas. The same also with pressure. Okay? It is has a directly proportional relationship. Na kung saan mas mataas yung pressure in a constant amount of liquid, mas mataas yung solubility. Okay. I'm sorry, my mistake. It doesn't change pala. Ayan. Sorry for that. I have to correct myself. The solubility of liquids and solid does not change with pressure. Ayan. Sorry for that. Ayan. So ayan, we have this Henry's law. It's just a simple calculation for you na ikuan ninyo. It's just a Henry's law where Sg is the solubility of the gas. K pala, I have to i-retract ay sinabi ko kanina, as the pressure increases, the solubility of the gas increases. So ayun. It has a directly proportional relationship based on this equation. So I have to repeat this PowerPoint. Ito, coupled until. So mali yung nakalagay dyan. So it's just a K is the Henry's law constant and Pg is the partial pressure of the gas. So ayan, Henry's law calculation, we will deal with this at the part 2 of our, and let's have here, ayan. Okay, it's a part 2 of our lecture na lang. And then this one here naman, ways of expressing concentration of solutions. Now this one here are discussed in your general chemistry, namely molarity, molality, mole fraction, parts per million, parts per billion, percent solute, and dilution, syempre. Pero ang ikuan lang natin dito is the mass percentage. You are all familiar to this naman. Mass of solute A in solution all over the total mass of the solution, by which this one can be expanded into a mass solute as mass solvent. So the calculations, another one here, parts per million, mass of A in solution and the total mass of the solution times 10 raised to 6. Makikita natin yan mamaya. Okay? Then parts per billion, ganun din, but in terms of the 9th factor. Ayan, so we will deal with this at the part of our lecture. So another one is the mole fraction. Okay? So the mole fraction of A is equals to moles of A all over the total moles in solution. So ayan lang, mole fraction. Yan. And the next one is the molality. Molarity pala. So it's just a moles of solute all over liters of solution. Okay, tandaan niyo guys, when we say moles, I have to emphasize this one. When we say moles, tandaan niyo guys, itong equation na to is expandable. When we say moles kasi, ito ay mass, sorry. It is mass all over the molecular weight of the specific solute. So pag in-expand nyo yan, the molarity can be also expressed in terms of mass. Mass of solute here all over the molecular weight of solute in terms of grams per mole. So ba nakikita yun? Yun doon nakikita yan sa may ating periodic table. The sum of the atomic weights or dependent on the present. And then the liter of solution. So ayan yung expanded form niya. Ayan. And then another one here is the molality. Ganun din, it is expandable. But ang i-consider lang natin dito is yung mass ng solvent, hindi yung volume. So may relationship yung density dito or depende dun sa may given na ikuan natin. Okay? Next naman, okay, mamaya we will deal with this part of our lecture. Yan. We will deal with this later. So changing molarity to molality, okay, you have to consider just the density, ayan, the relationship, the mass of solute, moles of solute, mass of solvent to get the molarity, and the mass of solution from the mass of solution using the density and the volume solution to molarity. Mamaya, magkakaroon tayo ng mga discussions for this one. Ayan. So, Mamaya na yung mga yan. This is for the part of our solution. Now, this one here is the colligative properties of solution. This one here will be discussed on the part 3 of our lecture kasi masyado pang mahaba tong slides natin. Okay, I'll just give you an overview for this one. So we will tackle the 4 colligative properties of solutions, which only depend on the number of solute particles present, vapor pressure lowering, boiling point elevation, melting point depression, and osmotic pressure. And also, we will also have yan. May mga formula si apat na yan. And we will also consider the Bandt-Hofmann factor for the presence of the ionic solute. For the electrolytes, okay? For the electrolytes. May kita natin yan na on the part of our lecture. So that will be all for part 1 of our lecture. So see you in the next part of this lecture. Thank you very much for listening and see you again.